noise, okay? So just that you're all aware that we are recording this. I'll just admit there's a couple of more people arriving. But basically it's all really about learning what you can about the program today. We really hope you find it exciting. Obviously, we'd love to have you here studying this master's. And that's really what it's all about. So get engaged, ask any questions you have of Francis. There's no problem, or follow up with me afterwards. You're very welcome. Francis, I might pass it over to you there if you want to give a bit of information or share any slides about the program. And what I'll do is I'll admit anyone who arrives while you're talking anyway. Okay?
Thanks, Nessa. Let me just
Sorry,
load up my slides here.
Just while you're loading up the slides, just anyone who isn't speaking at the moment, we'd really appreciate if you could just stay on mute. We will have a chance to have a kind of quite an open discussion just after the slides. But if you can, just please make sure that you're on mute for the duration of the slides piece. That would be really great. Okay? Thank you.
Okay, hi everybody. I'm Frances Judge. I'm a lecturer in energy engineering in the School of Engineering here in UCC, and I'm also the director of this Masters in Sustainable Energy, which I'm going to tell you a little bit about today. Oops, sorry. So this is a taught master's program. The way it's broken up is it consists of 90 credits, which is broken down into 10 5-credit taught modules. There's one 10-credit module, and there is a 30-credit research project as well. So first of all, what is 5 credits exactly? So usually it's one subject it's 5 credits, and 5 credits represents about 125 hours of student effort in total. So this includes, your lectures, which is usually 2 hours per week. For a 5-credit module, tutorials, any reading, any assignments that you have to do, studying for your exams. So how that works out is about 40 to 50 hours per week of work that you have to do. So it is very much a full-time program. There are 3 semesters. Semester 1 from September to December, semester 2 is January to May, and then semester 3 is May to August. It includes a research project, like I was saying, so this is done in semester 3, and then the entry requirements are a level 8 engineering degree. So we've a minimum 2nd class honours grade 2, which might be a bit different to whatever grading systems you're used to. So there'd be a kind of a conversion applied. Or we would also consider an applicant with a strong STEM degree that might be in another area. One thing that we do as well, there are some people that apply and it might have been a while since they were in college, but they might be working in a technical role. So we do have a pathway into this course as well through recognition of prior learning. So that would all be part of your application. If English isn't your first language, then you need to meet our English language requirements as well. So like I was saying, it's broken into 3 semesters. So semester 1 starts in September. There will be an orientation that first week, 12 weeks of lectures and coursework. Week 13 then would be a study week, and then you'll have 2 weeks of exams. Christmas break, then you'll have a couple of weeks off. Back to it then, usually in the middle of January, for another 12 weeks of coursework. Now this year coming, or the current year, for instance, it's 12 weeks straight, and then there's an Easter break for 2 weeks, then a study week and exams. This can change a little bit just depending on when Easter occurs. Sometimes, you might have like 9 weeks of lectures or 10 weeks, and then a 2-week Easter break, and then back for another couple of weeks. So it kind of just depends on when Easter falls. So you'll have more exams then, kind of end of April, start of May, and then you'll be straight into your research project then. So just to look at the modules, so what you're actually going to be studying on this course. So we have a kind of a recommended list of core modules. In semester 1, these are here. So wind energy, photovoltaic systems, energy and buildings, ocean energy, we have a sustainable energy module and energy innovation as well. Semester 2, then we have these topics: clean energy futures, transportation, offshore wind, sustainability, bioenergy and circular economy systems. And then we also have this preliminary research project, which it kind of gets you going on your summer dissertation, which I'll talk about more in a minute. Depending on your background as well, you can actually substitute any of these modules for this one off this list of options here. So, like for instance, we have a very strong electrical engineering department here in UCC. So if your engineering degree happens to be in electrical engineering, then for instance, you might want to substitute one of these for one of these electrical engineering ones. But we also offer you the option to study subjects like hydrodynamics, finite element analysis, if you're a structural or mechanical engineer, perhaps. We have a very good course on data analytics. And then we have other courses over here. Again, some strong electrical engineering ones in semester 2, more energy systems modeling and looking at energy and buildings, that kind of thing. So it's actually quite flexible. But the core list is here, and that's kind of what we would recommend that you do if you don't have very a strong inclination towards any of these topics. But for all of these, you can look up the details of any of these modules. So if you just search, do a Google search for UCC Book of Modules, and you can put in the codes, and that'll give you details on the lecturer and the format of the module, what it contains, and how it's assessed. So I would strongly recommend you, if you are really interested in doing this course, go in and have a good look at what it is that you'll actually be studying. So in semester 3 then, so once you've finished all the taught components of the course, you will be doing a research dissertation in semester 3. Now, what we usually do here is we would propose a list of titles, and these titles, it might be purely academic research, but we also try to get projects that have an industry partner as well, in which case you would have, an academic supervisor and someone in industry who would be directing your project. You can also propose your own research topic if there's something that you're particularly interested in. So the projects are all supervised or mentored by academic staff in UCC or some of the research staff in some of our research centres. So the centres that would be associated with UCC and typically we work with on this course are the Marai Centre, which I'll talk about in a minute, and the Environmental Research Institute. We have an energy policy and modelling group, and we also have the Lear National Ocean Test Facility, which I'll mention in a second as well. So your topics are actually allocated in semester 1, towards the end of semester 1. So this kind of gives you a bit of time, if you want to propose your own topic, you'll have most of semester 1 to try and figure out what it is you're interested in and to try and find someone to supervise you. During semester 2, then the focus will be on just doing your literature review. So there's a 10-credit module there that's dedicated to this. We have support of a tutor as well to help you through your literature review. And then once you've finished your exams at the end of semester 2, you'll be into full-time research then for semester 3. So just to mention just a few of the different topics that we cover, we'll have a very strong research group in offshore renewable energy here in UCC. So we'll have people doing topics in wind energy, wave, tidal. We've had a couple of floating solar projects, we've airborne wind projects ongoing at the moment. GIS-based projects as well in any of the offshore renewable areas. There's also a really strong biogas research team here in UCC that's led by Jerry Murphy in the Environmental Research Institute. That group would tend to look at things like alternative fuels and hydrogen, biofuels, sustainable aviation fuels, that kind of thing. So there's always a few projects in that area as well. The Energy Policy and Modelling Group do a lot of energy systems modelling, modelling things like just complex energy systems and energy transmission using software like Plexos. And then we also, actually this year, we're partnering with EirGrid, who are the Irish grid transmission system operators. And they have a whole load of research projects as well that they're co-supervising with us in this area. And we hope kind of going forward as well that we'll start to bring in more kind of industry partners that will increase the breadth of the research topics that are available a bit further. Some of the research topics could potentially be laboratory based. The building here in the picture, this is the Marai Centre, which houses the Lear National Ocean Test Facility. So basically what this is a building full of all these very large wave tanks in which we test different types of renewable energy technologies. So, there's a floating wind platform there in one of our tanks. This is a wave energy device. So this is an option as well if that's something you're interested in. And is around the renewable energy lab-based research. There's an awful lot of other research topics, and there's a lot of skilled researchers down here who you could end up working with as well. And just to mention, I suppose as well, just to finish up for me, I guess, career prospects from this course are very good. The energy sector in Ireland in particular, there's a huge amount of momentum in Ireland and in Europe at the moment to try and decarbonize our energy systems. So, like for instance, Ireland, we have these very significant targets for offshore wind, for instance. So there is a huge requirement for for engineers, any kind of engineers, but people who are kind of well versed in sustainable energy as well to help us through this energy transition. So there are lots of opportunities both in Ireland and internationally as well in areas like project finance, for instance, project development, particularly in excuse me, solar, wind energy, onshore and offshore. Areas like resource analysis, surveying, any kind of operations and management of energy projects and decommissioning activities as well. So where people have gone in the past have been into engineering consultancies. So in Cork, for instance, companies like Feely Timony or Gavin and Doherty Geosolutions would do a lot of work in the energy sector. Developers, there's a lot of Cork-based renewable energy developers too, including Ørsted, Statkraft, SSE. We have ESB, DP Energy, Simply Blue, and those are just the Cork ones. There are huge numbers of renewable energy developers in Ireland and in across Europe as well, who are always looking for people with qualifications in energy, surveying and site development as well. And then also your technology developers, like the likes of your GE Renewables and Siemens as well. So that's it for me, actually, really. I think maybe a few questions now, if anybody has any.
Yeah, I might just jump in there, guys. I'm just going to stop the recording for everyone, and I hope everyone got a lot of information there from Francis's slides. But we're really delighted if you want to feel comfortable to unmute yourself, ask a question. There's no problem. That's why I'm actually stopping.